all of the different types of factoring that we've been doing, okay? So it's kind of like a review before the review. So when you are factoring, it's not always going to say, hey, these are difference of squares, so this is what you need to do, okay? It's not always going to identify like sum and difference of cubes. You have to be able to look at the polynomial and decide what is it, or which way do I need to, which method do I need to use. So we always do what? What do we do first? Every single time. Always look or check for a GCF. Always. Doesn't matter if it has 10 terms, we're going to look for a GCF first. Okay? And what that simply does is it makes the numbers easier to manage. So it says, remember, sometimes this will be the only way the expression will factor. And that's still a method of factoring. Okay? The GCF is the greatest common factor. So it says, remember that the GCF must be included as part of your answer. You can't just drop it off and be done with it, okay? If you take a 7 out, that 7 has to carry all the way down to your answer. Then you decide which method you will use to finish factoring, okay? And it's based on the number of terms. So how many terms do I have? If I have 2 terms, what we call a binomial, looks something like one of these. If I have 2 terms, then we are going to do either difference of squares. The key there is it has a 2 as your highest exponent. It's only 2 terms, and it has a 2 as the highest exponent, okay? Difference of squares means it has a little 2. So if it has 2 terms, difference of squares, it has to be subtraction, right? And we do the square root. So what is the square root of 4x squared? What's the square root of 4? 2. And then x squared would just be x. And what's the square root of 9? 3. And then we write it down again. And what do we have to put in the middle of those? Different signs. Negative, positive, positive, negative, whatever. Opposite signs. Okay? And then you would be done. That would be your answer for that one. All right? If it has 2 terms, and your highest number is a 3, then it could be sum or difference of cubes. And again, I'm going to put a little 3 up there to remind us that it has 2 terms, and then the highest exponent is now a 3. And this one could be addition or subtraction, right? So the difference of squares has to be subtraction, but the sum and difference of cubes could be either one. And that's where that SOAP, that little acronym SOAP comes in to help us remember what signs. Same, opposite, always positive. So for this one, you would do the cube root of 8. What is the cube root of 8? 2. I didn't show this the other day, but let me show y'all how to do cube roots on the calculator, just in case you don't know how to do that. So dot B. So if you do the little mustache guy, he has all kind of little keys there. You want this guy. And that lets you put any root. So then you put your 3 for the cube root, and then the number. Don't put your x cubed in there. Just put the number. So again, use that calculator. Let it help you out. So the cube root of 8 is 2, and so it'll be 2x. And the cube root of 27 is 3. Because remember, it's 3 times 3 times 3. Okay? So you use the calculator. And then I'm going to use those numbers to finish off that pattern. So it's 2x times itself. So 2 times 2 is 4. And then x squared. Multiply the 2 together. So 2x times 3 is 6x. And then 3 times 3 is 9. Then you go back and do your signs. What do my signs need to be for this one? The first one's positive because it's the same. Opposite, always positive. Okay, and then that would be your final answer for that. And it looks like we should be able to take something out of that last one, but you can't, okay? 4, 6, and 9 don't have anything in common. So that's if there's only two terms. It's either going to be difference of squares, if it has a little 2 exponent, or difference or sum of cubes, if it has a little 3, okay? All right, what if it has 3 terms? Kind of our go-to with the 3 terms is that's what we call a trinomial, and that is the multiplier combined. And you make your little MC chart. And really for both of these, I could do the multiply combined for both, right? So this one is the multiply and combine. And then the bottom one would be a what we call a PST, or perfect square trinomial. I'm running out of room, so I'm just going to. And again, a lot of us struggled with that perfect square trinomial, so you could do the multiply combined with it. The only time that, to me, the perfect square trinomial is really beneficial if it's big numbers, like if you have like 81x squared, and then at the end you have 64. I personally wouldn't want to multiply 81 times 64. I could, okay? It could be done with multiply combined, but the perfect square trinomial makes that a lot quicker, okay? All right, so let's do this top one. I would multiply 5 times 6, and I would make my MC chart. So my MC chart, I'm looking for positive 30, factors of positive 30, that combine to give me a negative 13. Watch your signs on these, because this one I'm adding because my multiply is positive. If I wasn't adding, it could be 2 and 15, right? But those would have to be opposite signs. We'd have to subtract because they have a difference. So I'm looking for which two numbers add to be 13. What do we think? Ten and 3, both positive or negative? Both negative. Negative 3 times negative 10 is positive 30. Negative 3 minus 10 or plus negative 10 is negative 13. All right, so then I plug it in. I do 5x minus 3 and 5x minus 10. A bunch of y'all missed this step. So this is a trouble spot. This 5x gets split up. That 5x squared gets split up as a 5x and a 5x. Okay? Then I do the GCF. There's not a GCF of 5x minus 3, so he just carries down. And the GCF of 5x and 10 is 5. And so that becomes 1x or x minus 2. That is your final answer. If I say this is my final answer, then you have 5 times 5, which is 25. That does not give me 5x squared. It gives me 25x squared, so it's wrong. Okay? A quick and easy check is to multiply the first two. So 5x times x would give me 5x squared, and multiply your last two. Negative 3 times negative 3, negative 3 times negative 2 is positive 6. And then if you really want to fully check it, then you multiply the 5x times negative 2, which is negative 10, and negative 3 would give me negative 13. But a quick check, an easy check, is multiply the first two and the last two. All right. The perfect square trinomial, again, is that this is a perfect square and that this is a perfect square. So what is the square root of 4? 2, so it's 2x. And what's the square root of 25? 5. And then I would put parentheses, and whatever this sign is drops down, and that is times itself. So the check is this guy. The important part is this guy. 2 times negative 5 is negative 10, and that doubled is negative 20. So it checks out. So then you put a squared, and you're done. So the final answer for this one is 2x minus 5 squared, or times itself. Some of us just kept it times itself, and that's fine. Again, If it's smaller numbers like this, you could probably go on and do, multiply 4 times 25, get 100, and then find your factors that way, okay? You're just going to have 2 matching, which is fine, but you'll just have the 2 matches. So this saves you, a step or 2. All right, and then the last one is what if it has 4 terms? What is it called? Grouping. Yep. Grouping is what we did yesterday. If it has 4 terms, it's the only one with 4 terms. Then you put parentheses around the first 2, parentheses around the last 2. Kind of a good rule of thumb, guys, is whatever this sign is right here. This is what we were struggling with yesterday on it. Whatever that sign is going to drop down. He's going to factor out. Okay? And then I take my GCF of each one. So what is the greatest common factor of x cubed and 7x squared? X squared. So I factor out or divide out an x squared. X cubed divided by x squared leaves me with an x. And 7x squared leaves me with a plus 7. Again, if this is a negative, you're going to take a negative out. Okay? We want the insides to match. What does 5x and 35 have in common? 5. It'll be a negative 5. Negative 5x divided by negative 5 is x. Negative 35 divided by negative 5 is positive 7. Again, this is one of the only parts that some of y'all were messing up yesterday, is y'all weren't taking out the right sign. So if whatever the third term, bless you, the sign of the third term, he's what's going to come out, okay? And a checkpoint is, do those match? If those don't match, you've done something wrong and you need to stop, okay? And then we go from here. We take out our GCFs, what we took out, and then what are matching leftovers. And that is it. If 5 was a perfect square, I could go further, right? And do it one more time and do difference of squares. But 5 is not a perfect square, so I would stop there. Okay? You always look for a GCF first. And then you have to go again, yes. The expression is prime only if it will not factor at all. So you can't even take out a GCF. It is very rare for it to be prime, to where it won't factor at all. All right, look at the next page real quick. This is what I want you to do. So the next page, there's several problems, but this is how we're going to work it. I want you to identify the following forms of factoring with the following letters, okay? We should have kind of coded that, like G is GC, or G is grouping or something, I don't know. Anyways, so the first thing you have to do when you're solving a problem is identify what is it, what type is it, okay? So let's start with the 2's, right? If it's 2's, it's either going to be a difference of squares, if it only has 2 terms, or a sum and difference of cubes, right? This one has a little 2, only 2 terms, and this one has a little 3. So go through and look at each one that has 2 terms and see, does it have a little 2 or a little 3? So number 1, it has 2 terms, right? So it's either going to be difference of squares or difference of cubes. Is it subtraction? Yes. And it has only 2 terms and it has a 2. Are they perfect squares? Yes. So it's going to be difference of squares, which is letter B. So identify that first, okay? And find another one. This one only has 2 terms, but what is the exponent? The exponent. It's just a 1, right? It's not a squared and it's not a cubed. So it's probably just going to be a GCF. So that's a GCF only. So find another one, 2 terms. What about 4? It's going to be, it's probably just going to be just a GCF because it's addition. So I think it's just going to be an A, but we can check it when we go back and factor. What about 6? It's a difference of cubes, right? So the letter D. What about 10? GCF. 11? Are they perfect squares? Yes. And is it subtraction? Yes. All right, what's another? 13, which one is that? B. That's all the 2's on that side, right? Go to the other side, same thing. Find only the 2's. We're going to omit number 17 because you can't even see it. All right, 18 has a lot more than 2, right? So it's definitely a GCF. It might be a difference of squares after you take it, but it's addition, so it couldn't be. Okay? So it's just a GCF. What about 20? It's not squared or cubed, right? So it's just a GCF. 21? Difference of squares, which is a B. 23? Subtraction and they perfect squares. 26? GCF. 28? Difference of squares, it's subtraction and they're both perfect squares. Yes, I have 2 variables. That's okay. Let's do that one real quick. What's the square root of 4z squared? 2z. What's the square root of 9x squared? 3x. 2z, 3x. And then what must I have in the middle of those? Opposite signs. And then you're done. So it's okay they have multiple variables, right? They're trying to throw you off with that. As long as they're both squared. If that 9 only had 1x on it, we couldn't do it. 30? Does it have a cubed? Yeah. Is 64 a perfect cube? Yes, it's 4. And so it is going to be sum of cubes. So D. 31? 33? And again, those have 2 variables. I can still take a number out, right? I just can't take a variable out because they don't have one in common. Okay? What about 36? He has 4. Grouping. So that's going to be F. I think it's the only one. Oh, no, it's not. Just kidding. Then I would go back and look for the grouping ones next because those are obvious, right? Those are 4's. So then this is a F. 29. What's another one? 22. Any on the front? Nope. So just those 3. All right, and then we only have our perfect square trinomials, right? Now, could there be a 3 term that you can only take a GCF out and it doesn't actually have a factor? Yes. Okay, it's still factorable. Okay, so look at 15. What's weird about 15? Is there anything that's squared? Yeah, quadratic, guys. This quadratic means that it has a 2. But it's a 3. It's a 3 term. So it's going to have like plus x and then plus a number like that. That's the setup. Okay, so it has to have 3 terms, but the x has to be squared, or the variable has to be squared. Okay, that's a quadratic. So 15 doesn't have that. So 15 is just going to be a GCF. What do they all have in common? The smallest number is 4, but 4 doesn't go into 10, so it's going to be a 2, right? So just take a 2 out of each thing. So 8 divided by 2 is, and I can't take any variables out. They all don't have x's or y's, okay? 4 divided by 2 is 2, and 10 divided by 2 is 5. I still factored it. It's not prime, okay? I just took, all I could do was take a GCF out. Same thing with like 10 and 2. All I can do is take a GCF out. I can't go any further. Okay? What about 5? It is trinomial. Does anybody in here really want to multiply 81 times 25? No, that's a lot. Okay? So then I look and say, okay, what if it's one of these perfect square trinomials? Is this a perfect square? What's the square root of 81? 9, so that would be 9g. What's the square root of 25? 5. Okay, multiply those two guys together. 9 times 5 is 45, and doubled is at 90. Yes. So it is a perfect square trinomial. What's my sign? What's this sign? It drops down, and then you're done. Could I do that as multiply combine? Sure. But whatever 81 times 25 is, okay? Is there another one like that that has, what about number 3? You're looking for ones that have pretty big numbers and that are perfect squares on both ends. It's a 3-term, and it's a perfect square. So it's good to know kind of those perfect squares on top of your head. So 1, 4, 9, 16, 25. What's the square root of 9? Oh, this one is. Square root of 9 is 3. What's the square root of 25? And what's 3 times 5? 15. Is 15 doubled 30? Yes. And so what sign do I have? Plus sign. And then make sure you square it. I know when we originally did those perfect square trinomials, a bunch of y'all, we kind of got confused with that. But you have to make sure that you can multiply those two together and get doubled, okay? Anything else you want to look at? You just want to start working? What if we did, let's do evens. Would that help? Yeah, let's do evens for homework. Are those grouping ones even? I want to make sure we get some of those. Yeah. Yeah, let's do evens. Like, finish working out the evens. I think we should, let's identify all and finish working out evens. So identify all. They should all have a letter by them. Does that make sense? And then actually work or factor just the evens. Did everybody hear that? So I need a letter by all of them. Okay, this was a perfect square trinomial. So they all get a letter, but then only the evens are going to get finished.